Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.5, problem 5.35 from the book Fundamental of Thermodynamics by BORGNAKKE. So, the statement of the problem is saturated vapor R1 R41 It means that in given data, the working fluid is R 410 410A, and the working fluid is initially dry saturated vapor. At 0 degrees centigrade in a rigid tank. So initial temperature T1 is equal to 0 degrees centigrade, and a rigid tank means that volume is constant. It means that volume is equal to constant, or we can write this as V1 is equal to V2 is equal to C. Is cool to minus 20 degrees centigrade. Final temperature is minus 20 degrees centigrade. Find the specific heat transfer. Specific heat transfer means that heat transfer per kilogram per unit mass. So find the Q, specific heat transfer. So here we start solution. So first we draw the PV diagram. So this is pressure in kilopascal, and this is specific volume in meter cube per kg. You can also draw TV diagram. So this is saturation curve, and initially steam is dry saturated vapor. Refrigerant is initially working fluid is dry saturated vapor. So first point will be on saturated vapor line. And this line is called saturated vapor line. So let's suppose this is temperature of 0 degree centigrade. Here temperature is equal to 0. This is point 1, and this line is saturated vapor line. So at this point V is equal to Vg, H is equal to Hg, and U is equal to Ug. So start point is this point. Now we know that Q is equal to U2 minus U1. So to find Q, we will find U1 and U2. So for U1 is not available directly in the steam table. So for U1 is equal to Ug, we will use formula H1 minus P1 V1. This formula is H is equal to U plus PV. So U is equal to H minus PV. And we know that U1 is equal to Ug. So U1 is equal to Ug is equal to H1 minus P1 V1. So H1, it means that H1 will be equal to Hg, V1 will be equal to Vg, and P1 is the saturation pressure of vapor. So we will find these values from the saturated steam table. So from saturated table of R410A, at temperature T1 is equal to 0 degree centigrade. Initially temperature is 0. H1 is equal to Hg, P1 is equal to pressure of vapor or pressure of gas, and u1 is equal to, sorry, v1 is equal to vg. So check here from the table. Here this is temperature, this is 410 saturation property table. So here this is temperature, this is pressure per liquid and pressure per vapor, this is specific volume plus per liquid and vapor, this is density and this is enthalpy. So here this is 0 degree centigrade temperature, 0 per 0 degree centigrade temperature. Pressure per vapor is 796.5. Pressure is equal to 796.5 kilopascal. H1 is equal to Hg. This is the value for H1. This is 422.5 and you can check this here. This is Hg. So H1 is equal to Hg is equal to 422.5. 422.5 kilojoule per kilogram, and V1 is equal to Vg. At 0 degree centigrade, this is Vg, 0.0326, and you can check here this is Vg. So V1 is equal to Vg is equal to 0.0326. So U1 is equal to H1 minus P1 V1. Putting values, H1 is equal to 422.5 kilojoule per kilogram minus P1. The value of P1 is 796.5 kilopascal, and pascal is equal to Newton per square meter, and V1 is 0.0326 meter cube per kg. This unit is meter cube per kg. So here this meter square will be cancelled with meter square, and now kilonewton meter per kg. So kilonewton meter per kg, kilonewton meter per kg. So Newton meter is equal to joule. So kilojoule per kg. So unit are same. So U1 is equal to 422.5 kilojoule per kg minus 796.5 multiplied by 0.0326 is equal to 25.9656. 25.9656 kilojoule per kg. So U1 is equal to 396.53 kilojoule per kg. This is U1. Now we are finding U2. So first we check whether point 2 is in wet region or in superheated region. So from saturated table of R410A at temperature T2 is equal to minus 20 degrees centigrade. Find Vf and Vg. So from the table, at temperature is equal to minus 20 degrees centigrade, this is Vf and this is Vg. Vf is equal to 0.0008. Vf is equal to 0.0008 meter cube per kg, and Vg is equal to 0.0646 meter cube per kg, and volume is constant. As volume is equal to constant, so V1 is equal to V2 is equal to, this is V1, 0.0326 meter cube per kg. So as V2 is greater than Vf and less than Vg, the value of V2 is greater than Vf and less than Vg. So point 2 is in mixed region. Mixed region is basically liquid plus vapor region. So this is constant volume process, and it will be like this. This is constant volume process, and this is point 2. So here pressure is constant. This value is for Vf for point 2, and this is Vg. So V2, and here is V2. So V2 is between Vf and Vg, and this is in mixed region. And here this is T1, here T1, and here this is T2 minus 20 degrees centigrade. Now to find U2, we will use formula U2 is equal to H2 minus P2 V2. So for this V2 P2, we can find P2 from the table, and H2 with the help of formula H2 is equal to HF plus X2 into Hg minus Hf. Here X2 is unknown, so we can find X2 with the help of formula V2 is equal to Vf plus X2 Hg minus Hf. Sorry, Vf minus Vg minus Vf. Vg minus Vf. So rearrange this equation. X2 is equal to V2 minus Vf divided by Vg minus Vf. So V2 is equal to 0.0326 minus Vf is 0.0008 meter cube per kg, and Vg is 0.0646 minus 0.008 meter cube per kg. So this will be cancelled, and X2 will be equal to 0.4984 sorry, no unit. This is X2. Now we can find H2 with the help of formula H2 is equal to HF plus X2 into Hg minus Hf. So first we find HF and Hg from the table. So from saturated table of R4110A at temperature is equal to minus 20 degrees centigrade, find HF and Hg. So check here in the table. So at minus 20 degrees centigrade, the value of HF, this is the value of HF, 169.8, and this is the value of Hg, 415.7. 169.8 kilojoule per kg, and this is 415.7 kilojoule per kg. So now, so H2 is equal to HF plus X2 Hg minus Hf. Putting values, H2 is equal to 169.8 kilojoule per kg plus X2 is 0.4984, Hg is 415.7 minus Hf is 169.8, unit is kilojoule per kg. So H2 is equal to 293.25. This is simple calculation, you can do this. Now find U2. So U2 is equal to H2 minus P2 V2, and you can find P2 from the table. You can here find P2, At temperature is equal to minus 20 degrees centigrade, P2 is equal to, this is P2 of vapor, 399.5. 399.5. 0.5 kilopascal. So P2 is 399.5 kilopascal. Pascal is equal to Newton per square meter, and V2 is equal to 0.0326 meter cube per kg, and H2 is equal to 293.25 kilojoule per kilogram. So U2 is equal to 293.25 kilojoule per kg minus 399.5 multiplied by 0.0326 is equal to, or you can directly find U2, which is equal to 280.22. Unit is same because square meter will be cancelled with square meter, so this will be equal to kilo Newton meter per kg, and Newton meter is equal to joule, so this is kilojoule per kilogram. Now specific heat transfer is equal to U2 minus U1. So Q2 is equal to 280.22 kilojoule per kg minus U1, which is equal to 396.53 kilojoule per kg. So Q is equal to, minus 116.31 kilojoule per kg. A negative sign means that internal energy, that the heat is rejected. Negative sign means that heat is rejected. And this is the end of the problem. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.